So we're very excited to welcome Dr. Kevin Taaffe. He is the Harriet and Jerry Dempsey Professor of Industrial Engineering at Clemson University with 25 years of industry and academic experience. Received his BS and MS in Industrial Engineering from the University of Illinois, then worked in transportation and logistics, including American Airlines and Sabre, before returning to academia to get his PhD from the University of Florida. Research interests include the application of simulation and optimization in healthcare, production, and transportation logistics. In particular, he focuses on healthcare logistics problems ranging from patient flow to operating room management to clinical space capacity management. He has worked with clinicians, administrators, managers, and support staff to identify and solve problems related to the patient and staff experience on the day of surgery. And I'm going to choose of my own to re-emphasize that last part and the importance of this collaboration, working with your clinical partners and the staff and the people who are actually going to have to implement the work that you do, which is something that he's really great at. So we're very excited to have you here from South Carolina. Thank you for coming up to visit us, and we look forward to your talk.
Thank you. All right, so thank you for that great introduction. I appreciate that. And I will be talking about things that influence that collaboration because it is so important on getting good results disseminated and getting each voice included when you're trying to come up with what's the best plan. So my talk today is going to be about impact of communication, coordination, and OR design on surgical patient flow and safety. So you may not often hear those three together. We talk a lot about communication coordination, but in recent years I've actually been able to do some work that's related to OR design. It's been really interesting, and I'll get to that. There's two pieces to this talk today. So the first one will focus on communication and coordination, and then we'll move into a design focus. Okay? So having said that, this first part will be how can mobile computing improve communication and coordination on the day of surgery. So, and I was really glad to have a quick conversation with Jordan right beforehand that he teed up this for me, asking about the paper that I had sent to all of you. But that paper is relevant to this talk and this work. And we began working with our hospital staff and trying to understand communication and coordination and the different delays and what causes them. And we went through that exercise of doing a simulation experiment with them in a room and getting their feedback. But it also led to this issue of, well, how do you get rid of those delays? So we were funded by the National Science Foundation to look at the creation of this of a mobile computing app, but bigger than that, treating it like a learning system. So this was work that was joint between Clemson University and the University of South Carolina. One of the few times you will see those two on the same slide and be nice to each other. It's been very easy to be nice to them lately because we've been killing them in football. But boy, about 5-10 years ago, it was wasn't good. So we had coined this to be Periop MLS. It was Periop Mobile Learning System, and we were really focusing on these three elements: improving individual workflows, resolving systemic issues through data sharing, and changing staff behavior. So that was kind of our goal through the project. And translating those into objectives, how to use mobile devices in Periop to increase that communication and coordination. So this is kind of the focus of using the mobile computing. Can we learn from the data gathered using the mobile app? And then can we use it as a training tool? So let's take a step back for a minute. Perioperative services. So this is often viewed as what will happen on the day of surgery. And we've spent a lot of time over the years working with different pieces of the Periop process from on the front end, as we're showing in the box here. Now, say that, oh, that's right, I can't point to these with, yes. So the main box that says perioperative stage, Preoperative phase, the operative phase, and postoperative. Well, in preoperative, we would look at what's the likelihood that we'll have on-time starts. So we would focus in on that part. We did a lot of work early on, just looking at different process improvement projects along the way, and eventually had enough knowledge to understand the complications with communication and coordination. Led to that paper, led to some initial work, and then ultimately to what we were proposing here. So mobile computing, this is, I don't think to some degree, not rocket science, not now either. It's very prevalent everywhere. You're not expected to look at all that on the slides. Let me just pick out the 3 key boxes. So, clinicians are facing competing priorities for their time and focus, right? So how do we capture that so that they get the information they need and not get distracted? Mobile computing allows hands-free, fast, accurate documentation. And finally, if they have that data, can the app suggest actions, indicate missed tasks to clinicians? Not actually ever do their job for them, but give them some better guidance, perhaps just a little bit of extra information so that they can make a better decision. It doesn't have to even be just, we're not talking about surgeons, we're talking about frontline staff who have maybe ways they need to prioritize their tasks. So this project, I failed to mention this at the beginning, with the University of South Carolina, we had computer scientists involved as well as human factors folks and more IEOR folks like myself. And so we were all working on this project together. And they had a heavy focus on app development. So this was kind of new for me, but I really enjoyed that interaction and understanding the perspective from a computer scientist's point of view, on what's important. So I gained an appreciation for the struggles there. But as well as the human factor side, I'm just thinking, okay, well, just the app needs to look like this and it'll work fine, right? But no. Granted, I am an IE, so I do understand this. I'm not being completely naive, but you do gain an appreciation for how other experts will view a problem and provide a better solution. So we went through this process. I'm not going to talk about all these different pieces, but just to say that there was a lot of work up front that led to the wireframing of this device, this app, and then to something that we could actually share with the staff and start to talk about and test and ask, what do you like or dislike? Is this addressing the issues that you're currently having? And hopefully to foster some conversation about that. So the programming and trials, and then down to the live use of the app, which of course that's like the dream, right? We almost got there, but I'm going to talk more about that here in a minute. I'm trying to decide what to do. I think I am going to pass on the video. It's about 3 minutes. I want to make sure that we have enough time. If I end up going fast,
you can post potentially.
Yeah, basically we were trying to give the staff a glimpse at what the app looked like and what kind of questions it would answer before we then sat them down and did some testing with them. So it's a 3-minute video. I can certainly post it. They did a good job with creating this, so I just want to give them credit for their involvement on this project as well. So I'm going to take there's several screenshots that we're going to look at what this app looked like. And it was an Android-based app where this was meant to be for any Periop staff, from surgeon anesthesiologists, CRNA, down to other frontline staff like the circulating nurse, pre-op nurses, any of the nursing staff, anybody that would have a need to pull up some information. Of course, nurse managers, those that are working in either pre-op or PACU or recovery. And once you choose into your view, you would get a certain amount of certain information that would be tailored to what your job function was. So in this particular one, this was for the anesthesiologist, and that's why they would have a green bar at the top basically telling them how many concurrent patients they had, because this was going to be a key issue. You can't have more than 4 concurrent patients, otherwise that you're outside of what the limits are allowed to be for managing your patient load. But the idea was to have a box that represented all the information you'd need on a patient for their status, as well as who is responsible for that patient. And it's just things like that they just they didn't have access to, but they were constantly wanting to talk to the person who is in charge of this patient, and depending on which piece of the process they're involved in, it could be somebody different, right? So a lot of phone calls and pages and things back and forth were causing delays. The little boxes along there with Preop and OR Prep and OR, these are basically checklists of when they completed something. So these boxes were there to show things that still needed to be done in order to complete that process. So this patient's in Preop right now, needing some things to be done. If we go over to the next slide, this one's going to be a blow-up of the window. If you were to click on Preop, what are the tasks that are still yet to be checked off? Okay, so we have all those ones dealing with the RN. So the RN hasn't really come in and completed a visit here. Labs and things, those were done, either done or not needed, because sometimes they'll just be checked if there is no issue with needing a lab or an implant, and so on. Okay, so
what's the color coding on the left? They seem to be grouped. Is that,
yes.
Is it a prioritization, or is it who owns the role?
Who owns the role?
Okay.
In fact, now that I'm seeing that, I must have taken this screenshot later after we'd made some improvements. I'm going to come back to that in a minute. But yes, so like the first 3 were basically lab and external to Preop resource related. Yep. The RN, so basically the primary Preop nurse. Then the 2 pink ones were for the surgeon, then anesthesia. And then the other ones are going to then be, the ones that are in gray are kind of these in-between tasks before you can begin surgery, but will be needed for the process to go from Preop to the OR. Okay. 2 more slides then for the OR and PACU checklists. For the OR, these follow more along the lines with what a system like Epic, whatever data management system the hospital is using. A lot of these will be checked off just by the CRNA or whoever's in charge of that item in their actual system, and it would populate to a tool like this. So those ones in Preop, though, those are much more manual driven and not always recorded in Epic. So that was one of our struggles, was to make sure we could collect the right amount of data that would give us the information we needed. So a few more screens just to give a sense of the kind of things that they could get to. They could look up at surgeon status and the OR status. So for a particular surgeon, Theodore Kelly is in OR 7 right now for patient Franklin Rice, and then surgeon Eric Burgess is in OR 6 for that patient. Okay, so, and again, you can kind of see the progression of how far they are along in the case. So, with this information, though, we took a lot of feedback in at the beginning, getting the voice of the customer and understanding what they felt as the main concerns. So, we weren't able to test this in a live environment. We had hopes that we were going to be able to do a pilot, but midway through the project, they decided to adopt Epic, and it basically derailed our end goal. So we had to manage it. This is very common in any kind of actual system. How do we deal with that, and how do we still get them the benefits to the host facility, but also from a research point of view? So what we were trying to then do, of course, was create realistic scenarios that we could share with them and get their feedback on, make sure that it's relative, relevant to the right resources, anesthesiologists, core managers, and so on. And basically behind the scenes, we were going to then implement a simulation model. So along the way with this project, as I was saying, we studied first case on time starts, we studied other facets of the flow, that we had built out portions of a simulation model, and then we said, let's put this all together into a full-blown simulation model that could track and represent these task times, basically populating in information that we would get from either a historical source or whatever we had collected on our own. So there's a long history about the benefits of simulation-based training, and that's partly why I had you read that particular article, and that was our use of trying to use some simulation-based training to try to encourage the staff to realize that no one person's delay is going to be the answer to solving the overall problem. Because it's so easy to point the fingers that that person's the one that's causing us the delay. It's never me, but if they could all realize that they're all part of the problem, then you can get to some point of improvement. So that's a form of simulation-based training. So this was a little bit of the interesting technical stuff on the side that we had some computing expertise, that IT side of things that I normally wouldn't get involved in. But I loved this concept, was trying to figure out how do we take this simulation model that we built and then get it to talk to the app. So we had this down at the bottom, a discrete event model that was, doesn't really matter what it was built in, but we built it in Arena. And we wanted to have a web application that would just be like a dashboard, what they would see either in Preop or in the OR, like at the nursing station or the charts, that the chart nurse would be able to look at. As well as the actual app that was sitting on whoever's phone that they had, that you would be able to access the information that way. The problem was that getting information from that simulation software back to the app and the server was a challenge in this first pass that we used. But so with a little better, more smart, sophisticated approach to building a database that would have the right layers for communication, and communication with a tool like the simulation program Arena, we were able to come up with a method that allowed, and those three that are in yellow, the Android app, the Arena simulation, and the web app, all to communicate. So what was really cool was that we could run this model for a certain amount of time and then stop it, and it would populate information to the server. We'd have a dashboard that would show current view of a set of patients in Preop or the OR, and they could also then see the same information in the app on their phone or tablet. Okay, so this was an example then of a view that they would see on the web application, the dashboard. Okay, so that we would be able to track those patients and show from Preop to the OR to PACU and where they were in the system. Okay. So this is just an example script that we would have created to get a sense of what what this environment looked like to the staff member. So don't need to read the whole thing, but just getting a sense of this is what we would walk through, and we would basically run the simulation up to a time at 6 a.m. and then we'd have a pre-op nurse and say that, okay, you are now at 6 a.m. and you're responsible for pre-op rooms 3 and 4, and you want to know who your patients are, which rooms they're in, and so on. And basically just give them some easy tasks on, are you able to immediately find the information you need? So we walked through these questions like this, and this was kind of our phase 1 user testing, if you will, to get some initial feedback on how things work for them. Okay. And it was this kind of back and forth that we'd advance the simulation for a certain amount of time, let it populate to a certain new time, and we'd ask more questions. Okay. And so we received a lot of feedback during this initial piece, and it, things that they were obviously able to clear up some confusions that we had put into the system from maybe just a little bit of lack of knowledge and not really seeing it until you actually test something, quote unquote, live, but in their environment where they can comment on what they would be doing if they were actually caring for somebody. And so one of these, and this is back to your comment, Amy, that one of the things that we did was make a switch in the way we had colored things. And we originally had just kind of had this shading going from one to another, and they really just thought, can we color code those by person, by role? So that was a kind of a simple change as an example of something that we did in a later version. Okay. So after that, then the bigger user testing that we actually did was to have them actually try to complete a task. And so the tabletop exercises that we did over a couple of semesters, and realizing that we had to just take at the will of how much time we could get them to sit down and help with this, because of their limited time and schedule. We had to do it over several sessions, but we basically sat down and had these tabletop exercises in kind of a conference room setting with different staff members, and did use that system now that we'd already set up, and looked at scenarios that dealt with lab tests, missing consent form, and an H&P updating situation. So each of these would be tasks that nursing staff would have to, they identified these as potential ones that tend to cause them the most heartache. And time wasted, frequent checks for updates when there was no update. That would be the one that I'm going to show here now with the lab tests. And try to get a before and after sense of what they felt like with and without the tool. Okay, so we still then had a written scenario for this one as well, and basically gave them a needs survey. So trying to get the sense of what they felt like their ability to complete these tasks are currently without an app. Then go through the application using the written scenario, take that same needs survey again, and see if we get a sense of a difference between their answers pre and post using the app. Okay. So for this for the lab test survey questions, and I'm sorry, I don't know if it's going to be super readable, but I'll just hit a couple of the highlights. So the three columns, without the app, with the app, and then just the basic difference. And so the first one says, I'm able to quickly obtain the information regarding the status of patient labs. And so this is just giving them a result that we got from that difference for the set of nurses. So that was probably the biggest one, I think. The second from the bottom, the access to lab status information supports communication between users. Was also a big one. Jumping all the way to the bottom, I'm satisfied with my access to lab status information, a little bit below just a typical value of 3 that you would hope that you would get from just if everything is just okay, to above a 4 after using the app. So I mean, and it wasn't like the app was some holy grail, but this was a good indicator to us that there were things that they struggle with in the job today that a mobile app could definitely fix. And the problem that we were experiencing is we couldn't implement this and pilot test it. So instead of doing it from that point of view and being able to report a result based on live testing of our app, we instead basically rolled out our recommendations about the project to our hospital partner so that they could recommend these types of changes in Epic. So Epic is still controlling all of the IT functions and rolling out of updates, but Epic is, there's all kinds of things you can turn on as additional pieces within the typical software solution that they roll out. So based on things that we learned from the frontline staff, there are things that they would like to see in the information that they have available. And so those are the kind of things we were trying to then encourage the hospital to do. So a couple of takeaways from this this project. I mean, I'll first just mention a couple of things that are on the slide, and then just overall that, you know, even any of the nurses, even the ones that are really experienced, struggle with this concept of knowing when labs are going to be ready, and they're constantly going to the system to check for updates, and so there's just a natural additional distraction that doesn't need to be there. And I guess what I basically had said a couple of minutes ago on the prior slide kind of goes with the second bullet, that this was giving, while we couldn't do the pilot test, this gave the nurses a voice in how to change the way that data are used and presented to in their organization. One thing we did also pick up on is with with an app, and you have the ability to push out notifications to whoever the user is. So we recognized that and used it, but we also got some complaints about that we probably had too much use of notifications, so we had to be aware of that, and that's not uncommon in a healthcare environment. There's a lot of studies in anesthesia that's done on notification fatigue, alarms, and things of that nature. So you have to figure out what's the best way to get the information to the users. So just coming back to the three goals. Now, and granted, what I'm presenting today was more on specifically about the app, its development, and how we used it as a testing tool. So, but in and of itself, that wasn't really addressing improving individual workflows, but it was in terms of the communication of the workflow. And along the way, part of this project, as I said, we really were digging into individual things going on in pre-op, in the OR, and in packaging. So, we really did look at a lot of the individual workflows there, addressing the data sharing and access, and especially this, and then back to that paper that I sent to you. One of the things that these two projects and research areas, the focus was to see how can we use tools like simulation modeling in improving staff behavior in terms of learning about what your job looks like in relation to those around you, and how do you communicate your needs appropriately. So this was a 4-year study, so a lot of publications out there addressing different facets of the work that we had done. Okay, so that was part 1. We were looking at communication and coordination. So part 2, we're going to switch gears a little bit and talk about design. And so still staying in the operating room focus, and but this project, we're going to look at influential design factors on safety and performance in the operating room. And it was a study funded by ARC. But I think one of the more interesting pieces about this is, although based on the number of people shown on this particular research, it's Clemson Architecture was also involved in the project. In fact, they led the project. And the project was set up where we had 3 focus areas. One that was on a human factors piece, another one that was on an architecture piece, and then my piece was on evaluating traffic flow and movement. But the architecture piece, all 3 of these were equally large research studies. And what the architectures group was doing was looking at the built environment, trying to figure out, well, what should the operating room look like from the walls to the windows to doors to equipment, movable versus fixed items that are in the OR. And the main job on my end was to look at how things flowed, in particular people moved inside the room. So it was really neat to work with an architect because this is typically not what we do in a lot of projects. Although what I was saying, I think, to a few of you is it brought back memories because back when I worked for American Airlines and I was doing some simulation modeling, I did work with architects back then. We worked with the architect arm of American who was building new facilities at different international terminals around the world, and they'd bring us in to try to build a model to say, well, if we build it this large, do we have enough space? Can passengers connect in 30 minutes? Back in the day, that was what the requirement was, and so on. All right, so let's talk about the operating room. And do you have enough space, and where should things be? So I really should have shown a picture with the nice, pristine, beautiful OR that grabs all the attention, and then shown one of these pictures, because it's that contrast of, okay, this is what it looks like in a perfect world, and then here is what it looks like when people need to do their jobs, right? So how do we address where these people need to be, where the equipment needs to be, and manage it in a way that allows a design to help minimize the issues that could arise. Try to make that environment as safe as we can. So there are policies out there in terms of OR design that architects will use for designing what the room should look like, space and so on, but they're not really backed up by any quantitative measures that deal with staff safety and efficiency. So, so we really wanted to try to figure out a way to address that. And this is one of those things where it was really neat to come together with the architects and engineers to try to address what that gap could be and how to overcome it. So we defined some efficiency and safety metrics, and these would be like surrogate measures that we could use in our modeling to represent what could potentially lead to an unsafe procedure. So, goal of the research, informing the OR design using simulation modeling and examining relative impact of room-specific or procedure-specific factors. Okay, so most of the things that we're testing are room-specific issues, but we also looked at a grouping of procedures too. Okay, so the performance metrics, we were looking at density, occupancy, and movement to try to see, well, what metrics would we be able to assess based on having different levels of those density and movement. And again, we're trying to do this in one of the industrial engineering-based tools like simulation. What could we track and assess and provide feedback to the architects team and the rest of our project team to help. So, a very straightforward one would simply be just to track movement and tally up the total distances, right? And get a sense of total distance walked. total distance travel. And so there's a good number of studies that focus on this. It's just a few that I'm listing up there. And so that would be one. The second one, total number of contacts. So this was actually the one that's, to me, most interesting, because now what we're trying to do is measure any time you have two staff members in the OR and they're moving around, how often do they come within close proximity of each other to the point where we'll call it a contact. And we're trying to reduce as many of those as we can. And then the last one, total number of transitions near the surgical area. So we have basically what we'll call a surgical zone around the table, the bed where the patient would be lying. And if a staff member basically clips into that area when they didn't intend to go there, that's when we would report it. I mean, if a staff member is coming up to be at the side of the bed and do a task with the patient, that's not considered as a count there. So with all three of those, we could, we did a good bit of analysis on all three, but I really just wanted to focus on one of these, just to give you an example of how we could look at data coming out of the model, both in a descriptive way and a prescriptive way, and see what we can learn. So we'll just focus on the total number of contacts for today. And just a side note, if anybody's like wondering, well, what was a significant contact? And we chose to have it be 0.6 meters between two people. So there you have it. Just some questions. Can we figure out a good way to measure this total number of contacts using simulation? Which factors have an impact on that total number of contacts? And is there a relative impact that we can glean out from the different tests that we ran? In this project, we actually we worked with the Medical University of South Carolina down in Charleston, and on their main campus, we observed 35 surgeries, I think, roughly, and set up video cameras in the corners of the room. So we had 4 camera angles capturing the full length of the surgeries, and we then recorded or coded all of the movements from location to location. And basically we took an OR map and we broke it into zones. And so we had all of these different zones that we then just kind of watched the videos and recorded when they went from one zone to the next, how long they were in zones, and then where they moved to after that. So you have this constant updating. And so we focused on the 5 agent types listed there: circulating nurse, anesthesia team members, so that really could represent several different folks, anybody part of the anesthesia team, surgeon, resident, and scrub nurse. And so with all that information, I was talking with the lead architect researcher, and I said, we can take those 35 surgeries and we can build a simulation model and just play them back and first get a sense of how often, what was the movement like then. We can certainly tally up the total distance traveled and then see how many contacts there were and get the information based on just basically playing them back, right? So it's not really, there's no randomness other than in the course the software that we used, which was AnyLogic. The only randomness could have been, we couldn't have predicted how they would have moved, because there's an algorithm inside of the software that basically controls how they decide to move from one area to the next. But in the map, we can set up walls to prevent movement through those areas. So So they have to walk in only reasonable places. So in this would have been just a playback of those 35 surgeries, but now we're limited to just those 35 surgeries. And as you start wanting to move things around in the room, it gets tricky in terms of if you move something in the room and they were destined to go to a certain location, and now they have this kind of a path that takes them, and you've moved a zone that was in the corner, in the lower left corner, and now it's in the upper right corner, the movement's not going to look right. Right? So we had to get away from this kind of playback of every single zone counting to only the zones where they were actually destined to go to. And so we came up with a randomized model that was also phase dependent. So we broke the data apart by the preparation phase, the intraoperative phase, and then postoperative, just all the time though when the patient's in the room. And we tested the idea of whether we could use the concept of a Markov chain to basically advance the movement of the individual staff members. So in doing this, we could take the 35 surgeries and then allow for random movements of these different staff members and basically play out, create new designs, new factors as inputs, and be able to play how many ever replications of that scenario that we wanted to get a level of confidence in the result coming out. And this was just one example of some of the validation we were doing to look at before and after of the flows. Did the flows at least look proximate? In addition to looking at some of those measures that I mentioned, the playback total number of contacts versus the randomized total number of contacts. And so through those methods, we had come to the validation, through the validation phase of this randomized model that we could move forward with. So this became our baseline simulation model to use for our testing. This just one example of a probability transition matrix that we would have for any staff member in any phase. So this one happens to be for just the intraoperative phase. So once the patient's open, incision after incision, and they're actually doing the procedure for the scrub nurse. And so of these 10 zones, this shows the likelihood of transitioning from one of those zones to another, and then how long the scrub nurse spent in that particular zone. Okay. And we had a similar one, obviously, for all the different staff members. So now we're going to actually come to the point where we're going to compare the actual the factors and designs that were being tested. So this was just basically the base layout of our operating room being tested. Okay, and the factors that we're going to test, I'm going to list several of them here, but number of staff. So we're going to test running a simulation with 5 versus 7. Basically a small staff group for certain basic procedures, and then one that requires a few extra staff members. And a few of these, I think we all will probably agree that we should expect, just with more staff, we're going to get longer distance traveled, right? We ought to have more contacts, right? So some of we weren't expecting any kind of big revelations here. But we did, one thing that could happen is if you do have a very big operating room, certainly the total distance travel would increase, but maybe the contacts don't actually increase that much. So there was reasons for doing it, just because it was appropriate settings. Procedure type. So this was a pediatrics focused study, so we had a lot of pediatrics, but we also had we needed a comparison with those 35 surgeries, so we also spent time making sure we had a set of general surgeries as a comparison. Location of the circulating nurse workstation. So we had two choices, either in the corner of the room or in that location that's, although my graphic isn't as good, it really was more closer to the foot of the surgical table. Table orientation, so as it's set up right now, it's at an angle, but we also looked at it horizontally or vertically. Okay, so we had those three choices for the orientation, which may not seem like a big deal, right? But you have movement on both sides of the table, and this was a big deal to the architect. So it was that they really wanted to test this out. I thought, well, it's interesting. I really don't know what the result's going to come back at compared to like 5 versus 7. Well, I've got a pretty good idea. I know what's going to happen when I do that test. Room shape. So square versus rectangular. I don't have a nice graphic to show how it. We can get a little oblong shape here, but basically they stretched it out a little bit based on some past work and how the room could be laid out, and room size. So it says small versus medium. That seems a little strange because then you're kind of leaving out large. Well, we used to have a third setting, but for what I did in this case, we're going to test the small room versus kind of the base case size room. And then number of doors. So do we have one door entry or two door entry? So if there was a one door option, we stuck it up at the top on the left or on the right. And if there were two doors, then they would have been kind of diagonally across from each other. All right, so all of these become the options we were testing, and we wanted to understand the relative effects of these different options. So this is just listing them out with variable names and the testing levels that we had for each of the variables. So it really, if you go down to the bottom there, the last row, it says we had 192 different tests we were going to perform with the model. And again, I'm just showing data on total number of contacts. So we just did a couple different ways to let's grab some information and see what we can learn. So there's 192 scenarios, right? So we basically just took the top 10 and the bottom 10. Well, what jumps out at us when we look at the top 10? And we'll see for all of these the room size is set to small. Okay, makes sense. So what we have the most contacts when we have a smaller room. Surgery type is always pediatric. Well, that was an interesting find. So there's a little bit more movement in the pediatric surgery, and just people aren't standing in their one place as much in a particular surgery like that, and it's probably a lot of positioning and attentiveness and moving from side to side. Number of staff was always 7. Yes, I would assume that makes sense too. And the circulating nurse workstation is typically located at the foot of the table. So we get the advantage of the circulating nurse workstation being close, but it comes at a price to pay for having more contacts because there's not as much free flow movement now around the table. Okay, lowest 10 are basically going to have the flip on several of those that we just mentioned. Yeah, so with the last one, the workstation, now the circulating nurse workstation being pulled away and into the corner. But what about any kind of relative impact on these? So we also looked at this one an additional way, and what we try to do is pull out the level of contacts for a given scenario. So every scenario is actually kind of mapped out onto this grid, so all 192 of them, okay? And the lighter the lighter the box, the higher level of contacts. And the reason we did it was that I wanted to actually be able to see the numbers. You can't really see the ones on the dark side, so you normally would maybe think that you'd go darker for a higher level, but we wanted to go the opposite way so we could see the numbers. So this red rectangle right here, if we grab in just those two columns, these all represent a single door and pediatric surgery and 7 staff members. So again, I mean, some things that make sense. Now, we hadn't seen something come out on the slide before about single door. But so I've got those three factors in those two columns, and those two columns are shaded a little lighter, so they're the higher values of total number of contacts. If I reduce it down just to that one subset of, I guess, 6 scenarios, these, again, obviously they're still single door pediatric and 7 staff members, but now these are the ones where the circulating nurse workstation is at the foot of the table, and it's the smaller room size, okay? So confirming some of what we saw before in the top 10 and bottom 10, right? However, I can jump over to another area that has similar values and show that the pediatric surgery, 7 staff members and small room size, but these show 2 doors instead of 1. So, yeah, so I'm getting conflicting information about doors. Are they as, relevant as the other factors? What can I say from what I'm showing you here? I mean, I can't statistically say anything, right, from the data that I'm showing you. It's maybe good for interpretation and a little bit of dialogue, but you really need to go beyond just looking at this to get that relationship of individual factors to your outcome, which is total number of contacts. All right, and that's really where we're going to kind of wrap this up, is what if we put this all into a model and try to estimate what would these coefficients be for each of the potential factors that were in our model. And so now we have at least a way of quantifying some of those factors. So the size being small, so total number of contacts is negatively correlated with size, meaning that as we get size becomes bigger, this total number of contacts would go down. But it's because we're measuring this as the size is small here, you're seeing that we've got a positive number here of 13. Number of staff, when you're at 7, another high coefficient. Number of staff appears to be positively related to total number of contacts. So obviously as we increase staff. So these are the ones that are pretty clear. Circulating nurse workstation. This, beside the wall, has a negative relationship with the total number of contacts. So again, that was a desirable effect, right? To have the workstation at the up against the wall. The last one is the one I wanted to just point out, because this was the interesting finding that we came back to the architect team with, and so it wasn't a revolutionary result, but it did confirm something that they thought. And they're like, well, we have a feeling that the angled bed orientation ought to work better, and in our testing it confirms that, albeit slightly, because these aren't big coefficients, but it does show that the table being, and it's H and V, the horizontal and the vertical values are showing up as significant, but the angle does not. So, again, it's not a huge result, but it was an indication back to them that we could say there does seem to be a benefit of having an angled instead of horizontal or vertical, and with those values not actually being included. So were we able to use simulation to address total number of contacts? I believe we did. What factors have an impact on total number of contacts? And so we've gone through all that. I think there are a number of them that do have an impact. It's not really clear there's going to be any one that's going to be the most critical, and that kind of gets into the last idea. Can we identify relative impact? So we tried to address that in that last piece of analysis. So, like I said, this was a really interesting project because we were able to work with both of these projects. That's been one of the themes of my work, is trying to work with other departments and other institutions to really try to gain an appreciation for how people view problems. And then so you can use and bring your skill set, combine it with those around you, and you end up with something that becomes better than any one of you could have done on your own. So that's where I'm going to stop. If you have questions for me.
Thank you much. So I have a fabulous stack of cards, so who's going to be brave? Anyone? Anyone? Thank you, Isaac.
In your first project, do you have to take any steps to design the app to comply with HIPAA? Or is that causing difficulties as well?
So that came up a lot. You know, it was not our intention that the app was going to be containing any clinical information in it. Our goal was for it to be a tool to help coordinating events and status and be able to look and know where everybody is and have that information. But I can't tell you how many times we showed this to the nursing staff and they said, oh, can I get to the lab results in here? Or can I get to the patient's record? And I'm like, whoa, you know. So we so much wanted to go down that road, but we couldn't, you know, get to doing live testing. But that was definitely something that the nursing staff was very interested in being able to do. Yeah.
In the second project, did you consider, did you think about considering level of experience of the providers as a design factor? That is, experienced providers often have tacit knowledge that leads to them being more efficient in the workforce.
We certainly didn't have that in the data that we had. So, I mean, just in terms of how those subjects would have moved around the room differently.
If they're young, if they've been in the institution for a while and they've done that often and
You know, we collected data over several days with several different surgical teams. So we had a good variety, but we weren't calling that out as something we were trying to track and distinguish between more skilled versus less skilled. I mean, certainly that would be a factor that could affect how they interact with each other and how they choose to move from place to place in the rooms. Yeah. Yep.
How did you measure proximity, and also were you just visually observing when they were crossing regions, or did you use some other kind of tool or some other technique?
Yeah. So the second question I'll answer first was we had a monitor that had 4 views of the layout. So we were trying to do our best to just judge when they went from zone to zone, and we had our map sitting over here. We thought about when we're going to go back and do some more testing on a follow-up to have like something on the top where we could just overlay the map and have it a little easier, but I don't know that that's going to really help that much in the end. First question again, what was it?
The proximity.
Yeah, so that was really cool. I'll have to give all the credit to my grad student for that. But he got in there and figured out within the AnyLogic software how to figure out where precisely in like an XY coordinate system each of the subjects were, each of the entities. So just basically updating them every second, and any time that they crossed over that threshold of 0.6 meters, we recorded a contact.
Nick, do you have a question?
Yes, so I think so. Early on, you talked about how you, or in your paper especially, how you had to work with staff on the front line when creating like a simulation model. I'm wondering, when you do speak with staff, how much do you allow their reports to influence your model? Do you draw the line somewhere? Because usually when you're modeling something, there has to be a problem already going on, and that could be because the staff just don't know about it. So how much do you take their work into account when you transition into your own observation?
Well, and anytime that the model somehow isn't representing a workflow that they can comment on, I'm going to bring that in. If it's, you know, some of the, you know, ad hoc soapbox comments that they're just struggling with this issue, then maybe that's more of just listening, taking it in, and it doesn't necessarily go into the model. But, you know, often what we're trying to do is find a way to bridge the gap from this analysis component to something that they can relate to. And, you know, that's what I hope that what we were trying to accomplish in that paper was get them into a room and see something that was a simulation result that may be completely foreign to them, but if they could understand how it related back to their job, we could actually talk about process improvement, you know, how do we deal with coordinating delays, and things like that. I hope I answered your question. Yeah.
I just had a question about the simulation in terms of where you put like the big booms and all the other equipment that they have in the operating room. Was that incorporated into the simulation at all? Because sometimes people have to navigate around that and move around those kinds of stations.
Yeah, so we did that in a separate study from this one, with the architecture group kind of leading the way. They wanted to test certain room layouts with regard to booms and a C-arm being brought in and different things like that. So we'd box out certain parts of the room that could no longer be accessed.
Gotcha.
So yeah, and that's really I don't want to plug the Analogic software. That is one of the cool things that it can do by being able to really manipulate the room around. Yeah.
So time for one more. Go ahead.
For the simulation, did time factor into the study? Like, did a procedure that took 1 hour would differentiate from a procedure that took 6 hours?
That's a good question. We didn't see anything that, I guess we didn't really look to see if there were more per hour context from a short surgery to a long surgery. What we did do when we ran the randomized model is made sure that we had to scale things appropriately because of the fact that surgeries could take 30 minutes or 3 hours. Standard one and then appropriately normalize the number of contacts and those durations. Yeah.
So why don't we go ahead and thank our speaker. And then if you've got a question or two, I suspect he'll be willing to stay for another few moments, and otherwise we will see you next week for Dr. Lesion's talk.